Hello. In this video, let's build a linear regression model. We'll start from the basic mathematical equations and then move on to using libraries such as scikit-learn. We'll do it step by step using only Jupyter Notebook in this video. Let's take an example of salary prediction of an employee using their experiences. So we are using a columns experience, it's the input or a feature we can say. Salary, it's the output or the target which we want to predict. So this whole data set, I have taken it from the Kaggle website. First step is importing the libraries. In that, we need pandas, numpy, and matplotlib for plotting the graphs, and numpy is for numerical calculations. Let's import all those. Okay, then we'll move on to next step. The next step is we have to read the data and analyze it. So here I have downloaded the data into my local directory. So I am reading from the local directory pd.read csv file name. So the data frame looks like this. Okay, let's see various other informations of the data like df dot shape. So how many rows? 1,000 rows. Okay, and 3 columns. And what is the data type? df dot info. It has integer float. So I can see unnamed zero is not needed. That's a serial number of the columns. So we'll delete that. Let's see df dot drop column name axis equals to 1, in place equals to true. Okay, I forgot in place. Let's do it. See, now we got 1,000 rows and 2 columns. So let's move on to step 3. It's a data visualization step. So let's plot a scatter plot for this data. Consider experience and salary as x and y axis. We'll label x label, y label. See, there is a positive correlation we can see in this scatter plot. So the data points are going upward direction. So there is a positive correlation between year of experience and the salary here. We can see it in the graph. Then we'll move on to next step. The next step will be data preparation stage. In order to prepare the data, what preparation we have to do? So here we are using the data frames. So in order to do mathematical calculations, we'll convert those data into NumPy arrays. So X variable stores the array of experiences, Y stores the salary NumPy array, and let's move on to next step, that's calculation stage. Here we have to find the line equation. What is line equation? Y equals to mx plus c. Y is the salary, x is the input, that is experience in this example. So we have to find out m and c. So we can guess m and c values, but it is best to calculate using the equations. So we'll get the best line of fit with the same m and c values. So let's find out m and c values. So for considering m and c, we have to get the mean of x and y values. Let's take the mean of x variable and the y variable here and calculate numerator and denominator values for calculating the slope. Okay, this equation will give us the values of slope and intercept. After using slope and intercept values, if we draw a line, we'll get the best line of fit, which follows the trend of our data points. That's the best line, right? So, so while using this equation, slope and intercept will give us the best line of fit, we can say. So let's move on to next steps. That's the calculation of a line equation y equals to mx plus c. We know m and c from the above equation, and let's find out the y prediction. So means salary. So that is m value and c value. We are applying it here and we'll get the final y prediction. So we got the numpy array. Let's move on to next step. That's the error calculation. Means how far our predicted value from the actual value. The difference between y predicted minus actual value. That's the error, right? So that will be calculated using mean square error formula, y minus y prediction of whole square dot mean. So using this, we can easily find out how far our line is from the actual data point. That's what a mean square is. We'll try several different combinations of slope and intercept, and let's see how they affect the line and error.